Hi everyone, welcome to day 10 of PySpark Learning. So today we are going to talk about partitioning in PySpark. So what in our previous class we have a high level talked about we will partition and store data in disk, right? There are partitions which help us to improve the performance of this data processing in Spark. We talked about that. So today we are going to slightly deep dive into it and understanding how this is working and like how we can understand it's a partition is really helping us or not, right? If you wanted to relate, you can relate like partitioning is kind of an indexing where like you will be partition and store the data which based on how you are going to access the data, right? So there are two types of partition in Spark. One is in memory. In on your data frames and RDD, you can do the partitioning, which will help you to like fast your group by and all this kind of in memory operation. It will be faster. And you have on disk partition, which is where like when you are going to create a Parquet file or anything and store that into a disk, that means like S3 bucket or wherever the storage is, right? So that time also you can partition and store it, and when the that helps you, like when you are reading the data, your filter can be applied on the partition and get only the data which is needed. So that is where on this partitions comes into picture, right? So in this session we'll be talking more about that, and I'll show a demo which is helping you to understand how partition work, how you can verify this partition and everything. Okay, so we'll move on to the Databricks screen. Yeah, this is our Python window. I'm importing the pandas because I'm just creating a data frame. From that data frame, I'm creating our Spark data frames. So I'm using basic Python commands that help us to create a random data sets of 100,000 records. So I'm running this command. So what it is doing is like it create a pandas data frame, and from that I'm creating our Spark data frames, right? I'm also mentioning the columns and I'm mentioning the data set. And if you see that dfs.show, that is showing what how this data is, like you can see around 20 records it will be printing. So I have id, name, age and city columns which is having this random value. So like that I have 100,000 records, right? So this is stored into sample data.csv. Let us see, do we have something like that created in term? Yes, sample data.csv, right? So if you go in, it is created so many parts or partitions you can call it, right? Okay, you don't need to worry about that, but just understand that sample.data.csv is created. So what we are going to do next is like we are reading the same CSV file into a data frame and seeing like how many partitions do I have, right? So it is saying that 8 partitions. So let us see what I was talking. So you will see 8 from 0 to 7. That means 8 partitions are there. So that is the same number which you have seen, because by default the data frame is showing you the number of partitions which is there in the file. So that is where you got the number of partitions. So just keep this in symbol, right? You got a file and you splitted that the way you want and stored into multiple files. Like you created a folder and you created multiple files, and you have you may either based on the data size or maybe based on any of the frequently accessing column here or something, you cut it. So whenever you need to read the data, you have only read that particular file which contains the set of data. That is the concept of partition, right? So what I'm going to do here, like we got this CSV file, right? I'm going to convert, I'm going to create two Parquet files. One is partitioned, one is unpartitioned, one is partitioned. So when I'm creating partitioned, I'm saying like on which column I want this to be partitioned, right? You have seen I have this city column. I said okay, the data should be partitioned in the basis of city, and I also need to create a Parquet file that is need not to be partitioned. I'm saying both can be stored in my temp, right? So here you learned, okay, this mode, overwrite, if the file is there, it will write on top of that again. And partition by says like on which column you want to partition, or like create that multiple files, right? And where you want it to store. So my command is successfully completed. So we'll go to the catalog, go to this temp. You can see that partition and unpartitioned are created, right? So what is the difference between these two? Let me open this partition. Is it still running for some reason? Yeah, this job's completed, right? So let me go into unpartitioned first. So unpartitioned is as same as how you have seen CSV, right? You have like 0 to 8 partitions. So that means 8 partitions, and you see, okay, it is splitted, right? Let us go to partitioned. So partition is like a little more clear for you, right? They have created 9 folders because 10 folders, because you have the data from city 0 to city 9. So this has been created as multiple folders, and inside that you can see the files created, correct? That means like you have created a subfolder in the partition data. So that is called city equal to 0, city is equal to city underscore 0, and you have the data. So that what it says is like everything under this city 0 is going to be the data which is where the city is equal to 0, right? Now hope you got an idea how this partitioning works and how the partition data is being stored. So that is the key why I am showing you like this folder structure and storage. When I created something without mentioning anything, they are doing like they are creating the default partition. The way here when I said city, so they went picked up the data in city and created the folder according to that and stored the files in it, inside it, correct? Now you have two Parquet files, with one with this partition, second one is not partitioned. So what we are going to do, like we are going to execute these two, and we are going to read the data. I'm taking count. So here more than the execution time, what we need to understand is like the execution plan, right? So execution time, yes, definitely our goal is to increase, but there are other factors involved in like to get the performance, like the size of the file, because we have used a very very small file. So sometimes maybe it might think that, okay, like searching that partition rather than reading everything might be faster than the searching the partition. These kind of scenarios might happen, but let me explain this to here. Like I'm taking unpartitioned, and what I'm doing, this is part.read Parquet file, right? So either I can write my filter condition here. There are two filter conditions, either you can use where or you can use filter command. And next line, I'm like where city equal to city underscore 1 and dot count. Okay, so let me run this. Okay, it ran successfully. It took 1.36 seconds, and read that, okay, what like system is understanding you ran some command, right? So how this is going to work, right? This is an unpartitioned set, right? Like it is, so as I mentioned here, this is going to scan through the entire data and getting a data. So it should have come the pushed filters, like where did you apply the filter? It should have been pushed filters, but that's not coming because in some cases you need to use that here. And if you run this, you will start seeing the pushed filters here, right? So this is your filter. So basically you're reading the entire data and you're applying your filter on top of that. Let us understand that way, okay? Scanning the entire data. Now, so yeah, I have some statement I have written here. So that I'll run this partition data and we'll come back to the statement I have written. So I'm going to run this partition data. So partition data, I'm filtering the data. It took more time, right? Like it is 1.2 seconds and in 1.9 seconds. That is what I said. We are not here, like in smaller data set you will not be able to make out the difference. We have to, like here we need to understand how this is working. So I have created the partition based on city. So since they see this filter condition, right, on this physical plan, this is what we need to check, right? Optimized logical plan is saying like, okay, what filter we need to apply and everything. So here you can see that there is something here in the partition filter which was not there in our this unpartition set, right? So here system is saying that, okay, I need to scan this data, but I only need to scan this partition filter where city equal to 0. You might see a number, okay, you are saying, okay, like I gave city equal to city 0, what is this number? So this is a unique identification Spark applies on the columns to get it. Like maybe we have used the same column in our previous query, right? In order to avoid that conflict, this assign an unique identification number. It has nothing to do with your performance, but when you see this, you don't need to think, okay, I have to, okay, this is not optimized or anything. So when you see that your right column is applied in partition, that means like they are only accessing that particular partition to get your result. So this is how when you are going to read the data from the storage, this is how your disk partition is helping you to access the query faster. Think like you have like 20 years of data. If you create the partition and you know that you always take only a particular year of data to retrieve, you can easily retrieve the query by applying that year filter. So let me just give you a definition of what is partition pruning. So you may have heard this word. Partition pruning is an optimization technique in databases or big data processing framework where the query engine eliminates the unnecessary partition from query execution plan, improving the performance by scanning only the relevant partition. So here, so when I use the right filter and right partition, like when I was creating my storing my data, I use the right partition and my filter is also aligned. So it's like you are using the right index for your filtering query, right? This is what it is. So when you hear the like terms, you don't need to worry. We have many more terms to hear, but I'll try to go as slow as I can so that you understood why those terms are being used and how it actually applies or makes sense for you when you are going to start using these APIs, right? So hope you understood that how this partitioned and unpartitioned data retrieval is working. And if you use here instead of this city, if you use another column, this is not going to use that partition. So let me, yeah, I think in the interest of time, you can only try that out because we have many more to cover in today's session. So this is just a command like just to understand filter push down, right? So you have seen this push filter, right? In order to use that, like this should be true. That I was just testing is filter push down is true or not. That is this command. It is not actually like this is going a level inside and seeing like, okay, is it true? Why my push to filters are not showing and things like that. Okay. So now we are coming into the in-memory partition. So hope this is clear. All what we have covered is like when you are going to store this, right? So as I said, in-memory partitions plays a role when you wanted to like do some kind of operations, joins, grouping, filtering and everything on the RDD or data frames, right? You got to have a best partition in memory that help you to do all these operations fast, right? So here let us So here I'm not running any commands or going in deep. So we'll talk about how we would change the partition. Right now we have learned how you would like store a partition, like while creating a file, how you would choose a partition. You have seen that partition command, you gave city. So here we have something called repartition. Like I have like 10 partitions. So let me cut this code. So this is the command you can keep in mind: data frame name and rdd dot get number of partitions. This API will help you to get the number of partitions. So here I have 8 partitions currently, right? Because you know why it is 8, because like we had 8 partition and it directly pulled up it, right? So now what I'm saying, like I wanted to increase this into 20. I can do that based on the repartition command or API. So let me cut this off and run this. So I can see after repartition, my same df dot repartition data frame has 20 partitions. So why this is required, right? Like why repartition is needed? Repartition is needed in some cases. You know that, okay, this default partition is not making sense for me, or I wanted to partition this data based on a call. Now I gave city because city is the one which is used. But if you think that you wanted to partition against name, you can do that here. There are some terms I just mentioned here is like data skewness, right? That means like when you create this partition, some cases your data is like what do we say, not equally distributed, right? If you know machine learning and all, you may have heard this data skewness, outliers and all these things, right? So if your data is not equally distributed, there is like, however you have partitions, some of your query is going to take more time. So there we need to understand the data in detail and apply the right partitions. So repartition, and there are terms like salting, repartition, Coalesce. All these things are going to help you to improve, like resolve this data skewness, which we will talk in one detailed session, because I don't want to have a long video and make this more complicated. So repartition would help you to increase or decrease your partition count and based on any specific column, right? And if you wanted to like Coalesce would help you to repartition, like reduce this number of partitions, right? Like if you wanted to reduce these numbers in some cases while writing, right, rather than keeping so many partitions. By default, when you are doing all the operations, you had like 20, right? But while writing, if you have like 20-30 partitions, the writing is going to take time. You don't want that, right? You wanted to write it faster, so you might use Coalesce and reduce the number of partitions, right? So yeah, I can run this last command. So here df dot repartition command I use, it's same as this rather than using this one, okay? So here you can see that 20 got changed to 5, correct? Yeah. Okay, so hope this is I hope this is clear. So we will try writing two data frames into the storage. So what we are going to do is like to see the performance if you are reducing the partition. So we have one as Coalesced. So you know that df Coalesced is with 5 partitions and df partition is with 20 partitions. So we are going to run this code. So what is this bulletin function? No attribute name time. So why is it that? Right, so that like what we can do, we can pull our time from here and now we can run this. Still throwing error. what is the built-in function or method object has no attribute time. Let me have a look at it, like why it is throwing error. Yeah, I have used time, so that was causing the issues. Now I just directly use the time function. So here you can see I ran this code in between to test like why this was going wrong. So you can see like the first one, right, which is with repartition, which is having 20 partition, took 1.88 second, and the one with Coalesce, we are storing the same data. That is what you need to keep this in mind, right? You are storing the same size of data and same information, which took only 1.8 second. Here 1.88 second. There is a 0.08 second difference. 0.8 second difference. However, it is there, right? Like when you think about a large amount of partitions, you are planning to store it, and if you have no relevance there, better don't do that. Use Coalesce and uh, reduce the partitions and store it. Yeah, that is all I wanted to cover here. Like we talked about in-memory partitions, on-disk partitions, what is partition pruning, and like also we have this window which I'll be taking purely in one session. We have many things about job execution, like how all this information we have, which will be covered here. Also you'll be able to see those information. So we also talked about explain, right? This help you to get details, and you can also understand when you go deep into read it, right? Like we are passing the logical plan, then analyzing it, and optimized. Okay, how, like what is the best way? Since it is like one filter, you don't see any difference, but if when you have multiple filter, you will see, okay, what is the best way to filter it. Then comes to the physical plan. Physical is what we need to mainly look at. Do we have our partitions applied, push to filters are there, all these things we can review. It's like, are you using the seek or scan in like our traditional indexing method, right? So just keep this in mind. Keep that folder structure in mind. Like when you are going to create partition, it is going to create subfolders, and data will be stored inside that. So when you are going to filter, the subfolders are being filtered and the scanning is happening inside that, if you have the right filter based on the partition you have. Hope this is clear. We'll see you on the next video talking more about like the different data skewness and other partition related functions. Thank you.